Hello and welcome to the last video in our series of probability. This one's a pretty short one. We just got 3 slides to get through, so hopefully nice and quick. This one we're looking at independent events. Now, what is an independent event? An independent event occurs when the first event has no effect on the second event. Okay, and the key word is no effect or no impact. Okay. The big difference, or people get independent events confused with mutually exclusive. Mutually exclusive, okay, is if we look at a Venn diagram, that's mutually exclusive. There's no overlap, okay, so mutually exclusive has no overlap, okay. While a independent event, they can have overlap. There can be, tossing a coin and then tossing it a second time, okay? They can have overlap. You could get a 3 on the first and a 3 on the second, but the toss of the first coin does not have an impact on the second time. The coin is assumed to be fair, so there's no impact. There are 2 equations that we can use to prove an event or check. A lot of the questions that we're going to have around is not so much proving, but it's just checking if an event is independent. And then once it is independent, you could then use, say, the other equation. Okay. So the first, and this one is generally the one that you're going to use to check, is you're going to find the probability of A given B, and then check if it is equal to the probability of A. So let's read through this equation and see why this would make sense if they're independent. The probability of A given B has occurred is just equal to the probability of A. Okay. This has no impact. Yeah. Probability of A given that B has occurred should still just be equal to the probability of A because B has effectively no impact. So if, and this is a big if this first equation holds true, then we can say the 2 events are independent. Okay, the B has no impact on A. And from that, then, the intersection of A and B is equal to just the probability of A times by the probability of B. Okay, so generally we use this one to check, then it allows us to use this second one. Cool. So let's get into it. Okay. In the below table, survey results from 400 people from Do You Like Romantic Comedies? Is the film genre romantic comedy independent of gender? Okay. So we can use the following 4 bits of data, and we can come up with a whole bunch of different ways we can check if they are independent, because this question is asking, is the film genre romantic comedy independent of gender? It hasn't said, is liking romantic comedies independent of being male, or maybe just being male, or just being female. It says just is the genre. So this means like or not, and this is male or female. Okay. So there's heaps of combinations that we can have. We can have liking it and male. We need to check, is that independent? Is not liking and male independent? Is liking and being female independent? And is not liking it and being female independent? So there's 4 that we need to check, and all 4 of them, all 4 need to be independent for this statement to be true. Okay. The flip side of that is, if any one of those is not independent, then this whole statement becomes false, because it just talks about, in general, romantic comedy versus gender. Okay, so all 4 need to be independent for it to be true. Otherwise, it is false. And most of the time, though, generally, if one of those combinations, and I've got all these combinations listed here, if one of those combinations fails, then almost all 4 of them also fail. But if you get one that is independent at the start, then you need to keep going and checking the other ones. Okay. So probability of yes is 200 on 400. Probability of male, okay, is, and just quickly, they're actually, that list of events is using this second formula to check instead, but we can use the first one. Probability of male is 190 on 400, and the probability of yes intersect male there is 30 on 400. Now let's see if that is true. So 200 on 400 times by what was that, 190 on 400 becomes, let's go standard, 19 on 80, which is certainly different to 30 on 400. So that is not equal. So since they are not equal, that means they are not independent. That means gender is impacting whether they like romantic comedies or not. So is the film genre romantic comedy independent of gender? We can say no, because one of them has been a no. So we don't need to check the rest of them. We could check the rest of them though. The other way we can check it is that was using the second rule, is we can use the first rule. So probability of A given B needs to be the same as probability of A. So let's look at females liking romantic comedies. So probability of yes given female should just be equal to the probability of yes. Being female should have no impact. These two should be the same if they are independent. So yes given they're female means we're restricting it down to that. So that's 170 out of 210 total females is that. And that should technically be equal to just yes in general. So yes in general is 200 out of 400. This should technically be true, and we can see, simplifying, that's going to be half, and 170 divided by 210 simplifies to 17 over 21, and that is greater than half, so they are not equal. So that is not equal, so that is not equal, so they are also not independent. Being female does impact whether you're going to get a yes or not. So there we go. So there's doing a check. Okay. The other thing is that if some questions we are told they are independent. So if A and B are independent events such that probability of A is that, probability of B is that, find intersection, correct to 4 decimal place as well. The intersection for two independent events, because they're independent, is just equal to the probability of A times by the probability of B, which gives us 0.31 by 0.26 is decimal places is 0.0806. Okay. Pardon me. If A and B are independent events such that probability of A is 0.2, probability of B is 0.7, find the probability of A union B correct of 2 decimal places. Now you'll know, nowhere here is there any rules for union. Okay, there is a rule for intersection, and how can we relate intersection to union? Well, we can use the addition rule. So first off, what we're actually going to find is we need to find the intersection, and once we have the intersection, we can then use that intersection to find the union using the addition rule. Okay, so probability of A intersect B is just equal to probability of A times by probability of B, since we're told they're independent. So 0.2 by 0.7, which should be 0.14, is that right? 0.2 by 0.7, yes, 0.14. Then we can use the addition rule, which says that the probability of A union B is equal to probability of A plus the probability of B, take away the intersection of them, because it doesn't matter if they're independent or not, the probability, the addition rule still works. And so we get 0.2 plus 0.7 take away 0.14 gives us 0.9, take away 0.14 is 0.76. There we go. And that's it. That's all it is for independent events. Okay. You can use either of these two formulas to check. And if they hold true, then you can, if you use the first one, then you could use the second one. Or if you use the second one to check, then you can use the first one to check their independent events. Or you can also use them straight up if, like in these two examples, we're told straight off the bat that they're independent, which simplifies the problem a lot. That's it. Have a good day. See you. As always, if you have any questions, post them below, put it in the comments, Google Classroom, or shoot me an email. Thanks, and see ya.